Yeah, all right. So here, Newton's second law, there is a confusion because in the books there are some technical terms, and due to which a student can get confused how to answer, what to answer, and what these terms mean. So here is force is directly proportional to rate of change of momentum. What is rate of change of momentum? It is change of momentum upon time. Now replace proportionality sign, we'll put some constant. Why is it happen so? Because proportional doesn't mean equal. Proportion means if one thing is increasing, other will also increase. So that constant makes them equal. So uh, now, uh, but this is in this time, not always. In this time, this proportionality constant, when practicals were done on this to find this constant, it came 1. So this time it happened like that. So F is equal to then delta P by T. This thing not happen always. For this second law only it is happening, but for other time uh, it will come in some other formula also, these proportionality. At that time it would not be equal to 1, that will be something else. But when it will be happen, I will let you know. But this time it is F equal to then delta P by delta P is change in momentum. So remember, rate of change of momentum, change of momentum. Rate of change of momentum is change of momentum upon time. Change of momentum is delta P. And what is this delta P? But before that, P is mv. So delta P is what? Here we have two conditions. If mass is constant, generally mass is constant. But okay, let us suppose we are dealing it with if mass is constant, if mass is not constant. So first, if mass is constant, then delta P means final momentum minus initial momentum. Final momentum is mass into final velocity minus initial momentum is mass into initial velocity. We have taken v common, m common, so v minus u is there. V minus u means change in velocity. Change in velocity can be written as delta v. Any change can be written as delta that. So don't get confused, these are some new ideas you need to understand. Now the problem is if mass is not constant. So what are these conditions? I will tell you about it later. But if mass is changing, body is moving and its mass is changing, then this delta P, we can't do anything. We have to write it as it is. Delta mv. P is mv. So delta P will remain as delta mv. Not here. Here we had this final momentum minus initial momentum, and final momentum mass into velocity. Here mass is also changing, velocity is also changing. Maybe we can write it like final mass, final velocity minus initial mass, initial velocity. So nothing can be taken common. What can we do now? We can't do anything. So in this case, it is better to leave it as it is. Next thing, remember one thing I will tell you about when mass will not constant. First thing, generally velocity of objects are very less than speed of light. V is velocity of object or speed of object, and c is speed of light. The speed of light is actually 3 into 10 to the power 8 meter per second. This is such a high speed, we have never ever reached this. So we have just reached till this much, not beyond this. Little bit above, but not beyond this. So V is very less than C. If V is very less than C, that is the speeds which we often deal with. Bullet train speed. Bullet train speed is not more than 100 meter per second. So jet plane speed, Mach 3, 1000 meter per second. So all these speed are very less than speed of light. And if v is very less than speed of light, mass remains constant. Actually, this is Einstein theory, a concept which is very higher than what we are studying here and what is your scope to study. Second thing, if v is very greater than, oh sorry, if v tends to, actually it can't be greater than c. According to Einstein theory, it can't be greater than c. So if v tends to c, then tends to c means, like I told you, 10 to the power 7. If it further increases, then mass increases. And mass increases means now mass is not a constant term. It is also changing. So in such cases, we will leave it here. Second thing, which is more important, even at this, mass can be varying. Even at this, mass can be varying. As I have given you example of jet plane, it is ejecting fuel. It is ejecting fuel, so its mass will decrease. Or an asteroid entering in the atmosphere of Earth, it is burning away, its mass decreasing. So there are examples of varying mass. So even at smaller speeds, mass can change. But if it is tending to speed of light, mass will change. But if v is very less than c and mass is not changing, then here. So you have to keep these three things in your mind, whether v is very less than c or not. If it is, then delta p will be m delta v or m v minus u. If it is tending towards c or mass is changing, then delta p will remain delta mv as it is. So Newton's second law is all about force, and to understand the effect of that force, we need the term momentum.